Hello. My first video covers one of many possible uses for Tormach's USB I/O or input-output module. The USB module adds 4 relays controlled by PathPilot G-codes M64 and M65. Each relay can control or automate many types of external devices with the addition of only a few lines of G-code. Vacuums, coolant systems, many other devices can be turned on and off from within your G-code programs. The USB module has 4 inputs that can receive signals from external devices. I originally purchased the USB module to control my fog buster coolant versus flood coolant by calling a simple PathPilot subroutine that would turn on the flood coolant system by powering a relay if M8 is issued, or the fog coolant by powering a second relay if an M7 was issued. I've also been doing projects using Arduino microcontrollers and relays, and that's when I had a brainstorm for a project to see if I could develop an automatic tool changer or ATC by getting the USB module talking to an Arduino. The Arduino could control a stepper motor to move the tool turret into and out from the spindle, and a second stepper to rotate the turret to the appropriate next tool position. So the challenge was on. I don't own a Tormach ATC, but have always been interested in it. I thought this may be a way to have an ATC at a lower cost, realizing it would not be as fast or as efficient as the Tormach ATC, but still a challenging and fun project to tackle. My design follows Tormach's 10-tool position model. I use mostly Delrin parts for the tool turret and tool holder forks. I had much of the material on hand and only had to purchase the USB module, the Arduino, NEMA 23 steppers, stepper driver boards, control box, some switches, and 1 additional relay. All unique parts were milled on my Tormach 1100 or turned on my mini lathe, which, as you can see, is being replaced by my new rapid turn. I wrote 2 PathPilot G-code subroutines to do the tool change work outside of the main part program. Only 2 lines of code are added to each part program. The first G-code line is a global variable that the subroutine uses to trigger one of the USB module relays the same number of times as the next tool position in the turret. This global variable replaces the standard tool change G-code of, let's say for tool 3, T3, M6, G43, H3 for the tool length offset. You can see I've commented that out here. The second line of G-code added to each part program simply calls the tool change subroutines each time a tool change is required. These 2 lines of code always follow a G30 to ensure the spindle is at the tool change position. The first subroutine allows any tool in the library to be placed into any of the 10 tool holder positions, and when a tool change is called, the subroutine links the tool number with the turret position and tells PathPilot the next tool number and tool length offset. Does this by issuing an M61, let's say for tool number 3, Q3, and G43, H3, for the tool length offset. Once this is complete, the second subroutine is called. The second subroutine contains the tool change commands. It closes a USB relay, signaling to the Arduino to move the turret into the spindle. A limit switch on the turret rail signals back to one of the USB inputs that the turret is in place for the tool change. PathPilot is in a wait state using an M66 command while this happens. Once the turret is in, PathPilot proceeds and opens the drawbar by closing another USB relay, which is connected to the power drawbar. Then the spindle is issued a G53 Z-52, which raises the spindle to 52 millimeters below the Z reference position. which allows sufficient clearance for the turret to turn. Next, PathPilot triggers another USB relay the number of times as the next tool's position in the turret. For example, tool position 4 triggers the relay 4 times. These triggers are read by the Arduino using what's called an interrupt service routine, or ISR. The fourth USB relay signals back to Arduino that all next tool triggers have been sent. Arduino code then determines the shortest route to position the next tool, either a clockwise or counterclockwise turret turn. Once Arduino has issued the proper number of steps to the stepper motor turning the turret, it then signals another USB input that the next tool is in position for the tool change. G-code then lowers the spindle onto the tool and closes the drawbar. Arduino then pulls the turret out to the home position. I added LEDs to the control box to show when the turret is in, the drawbar is open and closed, and also the next tool triggers can be observed. After a lot of tweaking to both the Arduino and PathPilot G-code, the system is working very consistently. I do want to speed up the overall tool change process, but finding out the Arduino interrupt is very fussy on timing and/or speed that it receives the USB relay triggers. So other than trying to make tool changes faster, I'm happy with my ATC. The USB I/O is a great module and has virtually unlimited potential for automating and communicating with devices outside of PathPilot. Tormach is enabling our ideas, and I thank them for being such a great company. I've attached my control box schematic, a list of materials with approximate costs, and a short bio on myself. Thanks for watching my first video, and take care.